The limit this is equal to what? We have to find limit of this expression. If we directly put the limit, then 9 upon 0 within bracket 1 upon tan inverse x. Tan inverse x, when x tends to 0, tan inverse x is also going to 0. So this is 1 upon 0 minus 1 upon 0 type, means infinity minus infinity, which is indeterminate form, and this is also indeterminate form. So infinity into infinity minus infinity, this is indeterminate form, and we cannot solve this limit directly. So we have the some method to find the limit of this type. As normally we know L'Hopital rule, but we can solve this limit using simple expansion. Whenever trigonometric function is involved in the limit expression, then always or most of the time we have to solve them by using expansion. So put expansion of tan inverse x in this. So this is limit x tends to 0 positive 9 upon x, and this is 1 upon tan inverse x minus 1 upon x. Take LCM of this one. So limit x tends to 0 positive, means we are approaching 0 from right hand side, and this is 9 upon x, and within bracket x minus tan inverse x divided by x tan inverse x. So we have this structure, and we are going to solve this one. So limit x tends to 0 positive 9 upon x, this remains same, and x minus and tan inverse x expansion apply here. So x minus x cube upon 3 plus x raised to the power 5 upon 5 minus x raised to the power 7 upon 7, and so on. Use curly bracket here, divided by x tan inverse x. Same. Most in most of the case, if x is given, then by expansion some terms will cancel out, as you can see here. So this expansion we have x tends to 0 positive 9 upon x, or you can write x square directly tan inverse x, and in numerator we have x cube upon 3 minus x raised to the power 5 upon 5 plus x raised to the power 7 by 7, and so on. This square will cancel out by x square we take as a common. So use common in above side. So we have limit x tends to 0 positive. You can understand here, we can write 9 upon x square tan inverse x, and this one x square as a common. So x upon 3 minus x raised to the power 3 upon 5, and so on. So we have 9 into x upon tan inverse x, and this is again indeterminate form. After putting the limit as 0, directly 0 by 0 form we are obtaining. So we can apply, or normally we have, if limit x tends to 0 positive, then x upon tan inverse x we have normally is normal, no, this is limit is equal to 1. So this limit is also 3 is coming from this one. So 9 upon 3 will also come out. So this one will be so 3 into limit x tends to 0 positive x upon tan inverse x. I am explaining this step again because here we did some calculus mistake. in explaining, as we have limit x tends to 0 positive, and this was 9 upon x square, x cube upon 3 minus x raised to the power 5 upon 5 plus x raised to the power 7 upon 7, and so on. So you can take x square as outside. So 9x square, also tan inverse in denominator. So x square tan inverse x, and within bracket we have x minus, you should take x cube from this one. So 1 upon 3 minus x square upon 5 plus x raised to the power 4 upon 7, and so on. So we have this one. So limit x tends to 0 positive. Now you can see clearly 9 into x upon tan inverse x, and after putting the limit in this expression we have 1 upon 3 from this one. Because of other terms containing x, so this term will go to 0. So 9 upon 3 limit x tends to 0, x upon tan inverse x. You can apply 0 by 0 form, or directly we know this. So this is equal to 1. So limit is 3 into 1, 3. Otherwise, you can do one more step here. This was 3, and limit, you can, if you solve this by L'Hopital rule, so take differentiation in numerator and denominator separately, and differentiation of tan inverse x will be 1 upon 1 upon x square. Put a limit, so this one will go to 0, and we have 3 into 1, so 3. So limit is equal to 3.